presume we can kick things off. Let's start with introductions from all the three of you.
Yeah, 100%. Can start us off. My name is Chunda. I'm one of the co-founders of Ion Protocol. We're a protocol that builds native yield infrastructure for rollups in app chains.
Yeah, I can take it after. So I'm Jazzy, and I'm the co-founder of Zellic. We do a lot of hacking. I've been hacking my whole life, and we've recently moved into auditing a lot of AVSs and just a lot of shared security stuff. And yeah.
Very cool. And I'm Riad. I'm the CEO and co-founder of Cubist. We build key management infrastructure in this space. We think a lot about slashing, preventing accidental slashing, preventing intentional malicious slashing, and general other kind of security for AVSs.
Awesome. Yeah, I think the vision for EigenLayer is ultimately maybe becoming, should we say, a verifiable cloud for microservices in one way, shape, and sense. So I'm just curious to hear all of your perspectives in terms of, what systems, what kind of mechanisms for information flow control should we actually see that are missing today for actually see this vision be realized?
Yeah. Yeah, I can kick us off there as well. I think one of the large ones that I think is becoming more pertinent recently is, I don't know if necessarily this is actually protocolized or productized, but the idea of creating some kind of visual delineation between restake security and attribution between multiple different restaking platforms. We really don't want to end up in a situation where we're double counting security and networks and have network failures as a byproduct. And since restaking platforms inherently don't communicate with each other at a low level, these systems, it's up to us as kind of stakeholders in this ecosystem to really make sure that, one, we build the social standards around it, but two, we also build good data visualization and also allow third-party infrastructure that can help make sure that we have really good stake attribution.
Yeah, I agree with I agree with all of that. No, I think one of the main things that we just need is just more transparency on here's how the operators are actually operating, here's how the which AVS are they actually running, and how exactly they're running it. Because I think at least for most of the restakers, they can only they have a choice of a lot of operators, and we just want more transparency on are these operators actually operating honestly? If so, how can we prove that? And I think that is a very interesting problem that we will need to solve eventually. Yeah,
these are very good answers. I think what I'd add to that is if you look at the delta between think about it from the perspective of I have some tokens and I want to invest them somewhere. If I'm thinking about staking on Ethereum, there's sort of one dimension along which I need to consider. Is the person who is running my validator trustworthy? Are they going to be up long enough? Are they going to not get slashed accidentally? Are they not going to leak the keys? Whatever it is, right? But no matter who I go to, they're still participating in the same protocol. They're using Ethereum. And this is a protocol that's been beaten on a bunch. It's been running a while. We kind of know all of these things about it, and I just get to take that for granted. If I now instead am going to restake with, now I have a huge number of options here. I can restake with different AVSs. I can go with different operators under a given AVS, and now there's even more stuff that I don't know. Is that protocol sort of fundamentally good? Is it? And I think a lot of that ends up getting sort of swept under the rug. Oh, we're an AVS. No, that doesn't answer the question. That tells me something, but that tells me about as much as we run on an Intel processor. Okay, but what do you run? So I think building, really now echoing what the other folks have said, building this information infrastructure where people can, go to a website or somehow figure out this one is using these kinds of techniques. They've been beaten on a bunch, and we have reason to believe that they're good. And this operator is using these sort of best practices, and that's also sort of giving me confidence because there's now with an AVS kind of multiple things that can go wrong.
Well, that's actually very, very illustrative. Maybe looking at the landscape as it were today, I'm curious to understand, what could be the least common denominators for risk across, like the different user personas that you see here as it relates to AVS developers, as it relates to operators, as it relates to restakers, and maybe the people who would be consuming these kinds of services.
Sure, yeah. I think one of the, I'll pick off on the easy ones. I'll make your guys' life a little harder. One of the I think, least common denominators is thinking a lot deeper about consensus protocol design. Specifically, I think there's a lot of underemphasized dependencies on when we iterate and bring novelty to consensus protocol design. It actually completely changes the dynamics of risk when it comes to slashing, when it comes to frequency of slashing, severity of slashing. And I think right now, in kind of the colloquial conception of slashing, we put it in the mind of Gasper, which is Ethereum's kind of underlying consensus architecture. And the objective function for Ethereum, for the most part, is like anti-collusion, but the objective function for other consensus protocols may not be the same thing. And so slashing may be more frequent, but less impactful. Slashing could be even more frequent and also more impactful. It's just very dependent on the AVS use case and exactly how the builders of that AVS want to actually index on certain things. So I think that's one least common denominator. I think it's really, really important to emphasize that a lot more eyes should be on, especially.
Yeah. So to add to that, I think one of the other things that is really important, just because we have AVSs that do a lot of different things, like AVSs, there's a lot of different communication needed in AVSs that I think the operational security, just for the operators, also becomes super important because as an AVS, AVSs perform a lot of functions. They can do, you can program them to do almost anything arbitrary, which means there's almost arbitrary logic, and arbitrary logic that is running at the bare metal level. If it's running at the bare metal level, there are just a lot more problems you get than, for example, if your protocol is running in the EVM, because EVM is a very constrained state machine, right? Whereas AVM is just bare metal logic. So there's just a lot more security requirements for you to run an AVS more securely than you would have to run a normal node or even a protocol built on any chain. So I think that is just very important for all of the operators to know and learn about on how they can just manage their OPSEC and just general security practices on how to run infrastructure securely.
Again, great answers. It's difficult to follow them up, but let's see. I think one other that kind of counts as low-hanging fruit here is as people build new AVSs, I mean, because there's sort of all this design space, you're going to have a client that's specific to a particular AVS, right? So AVS 1 has software associated with AVS 1. AVS 2 has software associated with AVS 2, 3, et cetera. And those may or may not share any common infrastructure, right? There, SDKs will grow up. We will start to see, more and more sharing of code just because that's more efficient. But here we are, sort of in the nascent stage. And so, the operators are now you download a piece of software, run that piece of software. Does it have bugs in it? Will those bugs cause me to get slashed accidentally? Will they cause, I don't know, a halt in the chain? Whatever it is, right? So those software bugs are, probably right now one of the biggest risks because none of these things have been exercised all that much. Software just tends to be buggy, right? I mean, we have, I don't know what the standard number is, something like 1 bug per 100 lines of code, right? These are very complex systems. They have many, many hundreds of lines of code. So there's a lot of bugs out there that are still to be discovered, and I think a lot of those ramify for, the folks who are running the nodes, the folks who are investing, the folks who are trying to use whatever functionality is built on top. And so understanding, what is the origin of the software that my AVS is running? Is it building on some kind of, well-tested infrastructure? Is it, all completely new and uncommented? And I mean, this is a little difficult, right? This is the transparency of open source software is fantastic, except you have to go and read the code in order to benefit from that transparency. And I think that's where we stand right now. We're going to get better, but this is, for now, to me, one of the big risks.
Yeah, I think the common denominator for all three of these things is they're not very consumer friendly. So it's easy for us to talk about, and you can even call it easy for operators and AVSs. I think the hardest part about all this is actually how do you communicate this to the end restaker, the end consumer, or even the LRT.
Yeah, I mean, I just want to add to the open source security point where open source, So I think there's a misconception that like if the software is open source, it is more secure because there's more eyes on it, which we have learned over the course of the past 2 decades as a security industry that that's not true. As people believe that, hey, this software is open source and it's more secure, no one actually goes and checks it. So it ends up becoming more insecure because no one has actually taken the time to look at it because they believe someone else has done the work for them. And I think that is just a problem we will need to tackle as we get more and more open source softwares and more open source AVSs.
Now that we've spoken about the broader lacunae of things that actually need to happen, I want to use some of the remaining time we have to focus on more specific areas that we can actually address right now. Maybe starting from the operator standpoint and thinking about key management, which is something that you focus on, Riad. So I'm curious about like what the landscape looks like and what is it that could be the ideal future that you see for operators to do key management and delegation in a secure manner.
Yeah, that's a great question. So I think one of the things that right now we're sort of benefiting from is that sort of everyone recognizes we're in the early days, things are a little bit less locked down than they will be, right? There's no slashing right now, so no one's really worrying about it. Well, that's not true. People are worrying about it, but in sort of the back of their minds, it's like, someday we'll figure that out. And I think that same attitude sort of propagates a little bit to things like, how are we managing the keys? Well, it's testnet. It's not that big a deal. Like somebody steals the key, it's fine. So I think what we actually see, the truth on the ground is like, well, the keys are just there. They're on the hard drive. Maybe that's fine for now. Who knows? And we've seen this go wrong a lot of times, even in there was a famous example last year of a Lido operator that just like accidentally exposed all of their validator keys. Oops. And these kinds of things happen. We know that they will happen. The system needs to be sort of like the entire system needs to be, sort of resilient to that. But we also need to build the infrastructure in a way that encourages that not to happen, right? And I think right now what we tend to see is a lot of the software is sort of, new, as I've already said, newly written. And so things like, oh, well, what are we going to do about key management? Well, don't worry about it. We're just going to pull in this library. Yeah, the keys are in memory for now. That's fine. We'll figure it out later. So I think the way that we get from here to there, where we want to be, with sort of good key management, a lot of options, a lot of possibilities for keeping your keys secure. I think one of the most important things is to have a common language for talking about this sort of thing. So this is something that we've had conversations with the folks at Eigenlayer about, that we're actively working with the folks at Babylon about as well, and that is like, how do we build generic interfaces that let you do sort of remote key management, remote signing, in a clean way, no matter what your AVS design is. And I think once we have that sort of low-level sort of spec written down, people can start to implement it. People can start to build against it, and now that will just make life much easier. I think the biggest hurdle that we are seeing right now is every AVS that we talk to, where they're like, well, we want some remote key management, we want anti-slashing. Step one is let's like add to your software some ability to talk to a remote key manager. So we have to do that for every AVS. It doesn't make any sense. So I think to me that's a big one. Is we need to just like have the hooks in place so that everyone is kind of speaking us the same language.
Yes, moving on to app developers in one sense, but Jazz, I guess. Since you've been looking at the security landscape for a long time, curious to hear your take on how is it that like apps or AVSs that get developed can get good audits, right, and make sure that like developers are happy with getting some coverage, which is maybe missing from what audits do today. What needs to happen for audits to be good in the AVS ecosystem and landscape?
So I mean, the AVS landscape and just the whole like Eigenlayer ecosystem is so nascent that I just don't think we have any companies that really have experience with auditing like AVSs, right? So like, I mean, but if you think about it, like, what exactly is AVS? It is just a piece of software that has consensus, that has a P2P layer. So like I don't think we can go to like a normal auditor that has audited like your protocols on EVMs or like Solana protocols, because all of those protocols and all of those audits happen on like an application layer that's built on top of like a chain, Whereas again, like an AVS runs bare metal, so there is a lot more design space, which opens up which just opens us up to a lot more ways things can go wrong. We've also seen that with Cosmos, that like normally when we do Cosmos audits versus when we do non-Cosmos audits, there's just a lot more ways Cosmos app chains fuck up because they have bare metal access to the system. And yeah, I mean, so what we need from so if you think about it just from like a general security point of view, and like, and AVS is a very complicated piece of software, so like, I don't think like you can expect an auditor to just like fully audit it, just because, again, like, because the design space is so huge that like, what you need from an auditor is like, hey, like I have these very specific set of like requirements for my AVS. My AVS should not be able to do this, this, and this, because if these situations happen, these invariants break, this will cause problems. And your auditor should be able to like take these invariants and like situations and just go in and be like, all right, I will verify all of these core problems that don't happen. Because I just don't think for like, I just don't think it's viable for like you to expect for like you to expect from an auditor that, hey, like just go and run the magic wand and fix all the bugs, because that doesn't happen.
Awesome. Chunda, I guess someone who's working actively on developing EVSs here. So I'm curious about what your perspective here is to, when you think about how you want to minimize risk for your own service that you're developing and deploying. Are there, like other compounding constructions that you need to take into account, like, like poor constructions by DeFi yield protocols that might lead to what you mentioned earlier with regards to having proper attribution. So I'm curious to understand how you would develop confidence in terms of like your own EVS in relation to other third-party services that are being developed outside your scope.
Yeah, really good question. Something I think about a lot. So for context, what it means to build native yield infrastructure for rollups and app chains, to an extent it means allowing rollups and app chains to restake user capital at the chain and network level. So it means we have the responsibility to effectively manage what could potentially be tens of billions of dollars in capital that can be injected into the restaking ecosystem. And with that in mind, the most important thing that I think about now is the fact that there's so much empty space in the restaking landscape, where I feel like the conscientious opinion of a lot of capital delegators in the current market is, since it's a completely zero risk, or quote-unquote zero risk outside of contract risk system now, without the introduction of slashing, we can basically deploy capital as widely and as broadly as we want. And that there will be no ramifications and no switching costs or switching overhead of moving the capital once these kind of more, I don't want to say dangerous, but these more risk-on kind of features are then implemented. So the thing that we're conscientious about is, one, being very careful about where you actually initially deploy capital. Just because, and this specifically, in my perspective, goes to about two different things. One is sophistication of client software, and two is the kind of uniqueness of the underlying consensus model. When you innovate on consensus and when you innovate on client software, that's where you really have this kind of black open space that we have no idea what kind of risk you're going to be internalizing. Minimizing those types of delegations to those types of platforms until after you can kind of see them work in prod. And then to that extent, also within DeFi systems, it's really important to actually delegate access to sophisticated actors that can underwrite this risk. Even in our kind of hard-coded implementation, we have tiering of specifically like manager roles that can delineate how capital gets accessed. You can split that access between multiple entities. And the introduction, although it introduces centralization to a certain extent, of sophisticated actors who are doing all of this research and are going to grow into this market in terms of being able to underwrite and effectively approach these systems, are going to be essential in pretty much any type of DeFi product that wants to integrate restaked assets. The kind of way I think about it in context of DeFi is, in DeFi historically for over 6 years, we've been focused on underwriting this concept of like market risk, right? Things that we're very familiar with in traditional finance. No one has ever really thought and conceptualized about underwriting infrastructure risk. And that's the thing that I think we really need to do, put a lot more effort in DeFi in particular, and then to build more things that are conscientious of this new type of risk profile.
Awesome. I think we're at time, but just want to kind of leave this as an open question to the three of you. But do you have any advice for people who want to build AVSs? What are the best kinds of guidelines or things that they should have in mind, when they're actually constructing these kinds of applications on top of EigenLayer?
I have really boring advice, and that is build really boring stuff. And here's what I mean. Like exactly what Chunda has been talking about here. As you get really creative, I mean, complexity goes, through the roof, and suddenly there's a million things that can go wrong instead of just 10,000 things that can go wrong, right? So you can minimize your risk by just minimizing the number of ways in which you innovate, right? So like just the perfection is achieved. I don't know. This is like everyone knows this, right? When there's nothing more to take away as much as you can. Like strive towards that kind of simplicity and perfection.
Yeah, I mean, I'm adding on to that, like build boring things using really boring parts that have been battle tested. Like, do not write things from scratch. Use a library, use an SDK. Use something that has been around for a while, that has been audited, that has been looked at by countless people, is in production. Use old, boring parts, not the new shiny thing, because new shiny thing will eventually break.
My recommendation would be more from a personnel standpoint. Bring people in the fold that kind of spend a lot of time thinking about these types of things, or just keep them around. The kind of colloquial thing with all of us that we all keep is we're all nerds and we really like talking about it. So we'll be more than happy to give you our 2 cents on everything from consensus design, but to AVS architecture. But realistically, like we really need to bring and also encourage more people who are focused on these types of topics and making sure that they're a mainstay in the largest and most prominent pieces of infrastructure that we'll end up depending on in the future. And also use Cubist, because it's really sick.
You're not making my job as an investor easier by asking people to build boring stuff, but thank you for permeating this as advice. That's basically, I believe we're at time, but do we have any questions from the audience?
You mentioned like boring stuff, right? But from the other perspective, more thinking about the node operators and the people that want to restake, what would you say are the minimum stuff that an AVS should have for a node operator to decide a restake on you?
Wait, one thing I want to clarify. Minimum you mean by like feature set or by like from a security standpoint?
Yeah.
Security? I think from my perspective, it would be one, like protocol level audits is like really important. Like I keep harping about consensus design. Like that's, we look at, I don't know if Say is like a perfectly correct example, but they did that work where they brought in even individuals who were able to recognize like low level like VM exploits. And thankfully rewarded those individuals. Like that's extremely, extremely important. And I think everyone should be doing, like every AVS should be prioritizing that. I think another thing is infrastructure level monitoring systems. I know a lot of monitoring infrastructure nowadays, and making those things public. A lot of monitoring systems nowadays focused on like application level monitoring. But I really think, we build our own monitoring stack in-house. It does take some time, but it's not like too difficult since you're building that infrastructure. And I think public monitoring and public visibility into systems is also really important.
For me, if I were, an operator trying to decide, should I restake or should I operate for this or this, I want the lowest risk I can find of of being slashed for the wrong reason, right? So I want to understand the slashing condition. I mean, of course, I'm talking about the future now because still we don't slash, so we all trust one another a lot right now. But once the slashing gets turned on, I don't want to be slashed for the wrong reason, right? Because the software went wrong. Because okay, I mean, look, this is now an opinion, but like slashing for downtime, bad idea. It introduces all sorts of bad incentives. So I would very, very, very much avoid, AVSs that have kind of weird slashing conditions that don't seem to give me as an operator the ability to avoid the bad outcome just by behaving correctly. This is something that even in Ethereum we see a lot of. There hasn't been a huge amount of slashing, but to the extent that there has been, it hasn't been because people are misbehaving. It's been because there's been some like small screw up. And the Ethereum slashing condition is relatively light, right? It's relatively simple to understand. Adding more complexity there, this is going to become an interesting problem. So as an operator, I want to understand the slashing condition really well. I want to understand why it is built the way it is, like what incentives it's trying to sort of highlight. And I want to know that the software that I'm running will minimize the chances that I will be slashed for the wrong reasons.
Yeah, I mean, I agree with both of them that really having an in-depth look on the slashing condition is important, just because there can be slashing conditions that are too broad, and that is a big problem. So like just having slashing conditions that are super specific is like, it should be a very critical point that operators should evaluate. I'm like, hey, like even if I run this perfectly and there's some unexpected thing happens where my network goes down, will that adversarially affect my operations? Like ideally, if there's downtime, it should not affect my operations. The only reason I should be getting slashed is if I acted maliciously, or if something went catastrophically wrong. So yeah, like evaluating slashing conditions, I think, is a really important part there as well.
Awesome. Thank you. Thank you all again for this, and really appreciate you spending your time speaking about what needs to happen to make restaking secure.
Of course.
Thanks for
Thank you for hosting us.